So this is going to be part 2 of what's going to definitely at least be 3 parts for section 8.1. And if you glance at the instructions for the last group of problems that we just did, they look identical to this group except one word is changed. It's solve each system of equations using, in the last problem we were using the substitution method. That word's been changed to elimination method. And then the rest of this junk's the same. If the system has no solutions, say it's inconsistent. If the system has infinitely many solutions, write your answer in the form, this ugly answer. Just like the last group of problems, if the letters drop out and you're left with a false statement, you get inconsistent. So letters drop out and there's a false statement, it's no solution or inconsistent. Letters drop out and there's a true statement, there's infinitely many solutions, and we can write them in that nice form. So there's 2 methods, 2 primary methods to solve systems of equations. The substitution method is the one that we did first. We picked in one of the equations, we picked a letter, solved it for that letter if we needed to. We did step 1, step 2, step 3. So the elimination method is the method I prefer, and most students wind up using the elimination method more than the substitution method. Both methods can be used for solving systems of equations. For the elimination method, there's a first step that usually doesn't have to be done, and I usually only use the elimination method if this first step doesn't have to be done. The first step in the elimination method is to line up the x's and line up the y's. And this is usually done already. This usually can be skipped. In fact, if it can't be skipped, I usually don't use the elimination method and I'll use the substitution method. So if I look at problems 21 and 22, in 21 the x's and the y's are right on top of each other. That's what I mean by lined up. And that's the same case for 22. So in both of my problem 21, my problem 22, and your problem 21, the x's and y's are lined up. This step can usually be skipped. Now, step 2, I'm going to pick a letter to eliminate. And it's nice if you pick a letter that has opposite signs in each equation. It's helpful. It'll make your work easier if you can pick a letter that has a plus in front of it in one of the equations, and a minus in the other. It's not a deal breaker if you can't do that, but it's nice if you can. And for your problem 21 as well as my problem 22, the y is the letter I'd pick. So when I'm going to do number 22, my step 1 can be skipped because the x's and the y's are lined up. My step 2, I'm going to pick a letter. And I'm going to pick the letter y to eliminate. The reason it is because it has a negative in the top equation, a positive in the bottom equation. Step 3. Multiply either one or both equations by different numbers to make the number in front of the letters the same number with the different sign. So I've decided for my 21, my 22, and your 21 that I want to get rid of the y. I need to multiply either just one of the equations or both of the equations by different numbers to get the same number with different signs in front of the y. When I look at my top equation, 4x minus 3y equal to 10, and I compare it to my bottom equation, 2x plus, which really 1y equals to 10, I want the y's to have the same number in front of each y's, but with different signs. Now, multiplying the top equation by anything is going to make it hard to get a 1 in front of the y, but multiplying everything in the bottom of the equation by 3 will make the y have a 3y in front of it, which is the same number with opposite signs. So my step 3, I'm going to create a minus 3y in my bottom equation. So my step 3 is to make both equations have the same number, one positive, one negative, in front of the letter that I'm eliminating. And so to do this, I'm going to take the entire bottom equation and I'm going to multiply everything in the bottom equation by 3. I'm going to leave the top equation, 4x minus 3y equals to 10, and now I'm going to go 3 times 2x is 6x, 3 times 1y is 3y, and 3 times 10 is 30. Done with my step 3, and I'm really done with the problem, although it might not feel like it. Moving on to step 4, add the equations, or combine the two equations. Which is going to drop out a letter. And solve. So the two equations that I have now, the original top equation and the reworked bottom equation, I'm going to add them together. I'm going to go 4x plus 6x and get 10x. The 3y's cancel. Negative 3y plus positive 3y is 0. And then 10 plus 30 is 40. So I combined the two equations. I dropped out the letter y, and now I'm going to solve. Almost done. Step 5. Solve for the other letter. And you can use any equation. They all will give exactly the same answer when you go to solve for that letter. So this was my step 4. Step 1, I didn't have to do it because the x's and y's were lined up. Step 2, it doesn't really show up, but I decided to drop out the y's. This is my step 3. I made the y's have the same numbers in front of them, so I multiplied there. That's my step 3. My step 4 was to add these together and solve. Step 5, I think I could sneak it in right here. I need to solve for the other letter, so I need to solve for y. In the substitution method, it's easy to know how to solve for the other letter because you have a really good equation to use. I can use any equation. I'm going to use this equation, 2x plus y equal to 10. And what I'm going to do is I'm going to substitute x equal to 4 into that equation because that's what I came up with. I'm going to go 2 times 4 plus y equals to 10. This is going to give me 8 plus y equal to 10. And then I'm going to minus 8 minus 8. And I'll get y equal to 2. There's my answer. I see x equal to 4, y equal to 2. When I go to write my answer, I'll write it as a point. So my answer for number 22, which I can check, but that's such a nice answer that I probably don't need to check it. If it was a fraction, maybe I'd check it. So 5 steps. First one I didn't have to do. The second one really was just picking a letter. The third one's the one where you have to be clever. If you can get the third step done right, it just falls apart. So for your 21, you'd probably want to do the same thing. You're going to skip the first step. You're going to pick a y, and you're going to make the top equation, you're going to leave the top equation with its positive 2y. The bottom equation, is going to be easy to make it have a negative 2y by multiplying everything in the bottom equation by 2. Because my goal in my step 3 is to make the letters have the same number except one positive and one negative in the letter I'm trying to eliminate. I'm trying to eliminate the y. That's why it's called the elimination method. You're eliminating one of the letters. And I'm going to do that by getting the same number with different signs. Our 23 and 24 are just different enough. So I'm going to do 23 and I'm going to skip 24. So for 23, the x's and y's are lined up, so I can skip step 1. For my step 2, both the x's have positives in front of them, both the y's have negatives in front of them. Makes it a little bit harder. For step 2, I need to pick a letter to get rid of. You can pick x or you can pick y, and you can get the right answer if you pick x or y. There's not a wrong number to pick. If I look at the numbers in front of the x, the number in front of this x times 2 equals that number, but the numbers in front of these y's aren't multiples of each other. If you have your choice, you should pick a number, the numbers that are multiples of each other. It makes less work. So I'm going to pick the x, but you could pick the y. And now for step 3, this is where it takes being clever. I need to get the same number in front of the letter x. I need the same number, but one positive, the other negative, in front of the x that I'm trying to get rid of. And for me, because 4 is a multiple of 2, I'm going to make this x have a 4 in front of it, because it's easy to make this x have a 4 in front of it, but I need to have one positive, one negative. I'm going to make it have a negative 4 in front of it. So the first algebra I'm going to do is I'm going to multiply everything in the bottom equation by negative 2. I'm going to leave the top equation at 4x minus 2y equal to 7, and then I'm going to go minus 2 times 2x and get minus 4x, minus 2 times minus 5y and get plus 10y, and then minus 2 times minus 3 and get positive 6. Done with the hard step. Now I'm down to step 4. I'm going to combine the two equations and solve for a letter. So I'll just put a vertical line or horizontal line under them. I'm going to add the x's here. They cancel. I'm going to combine the y's. If they have the same signs in front of the numbers, you add. If they have opposite signs in front of the numbers, you subtract. So this is going to be minus 2 plus 10 is going to give me 8y. Really? Equal. I'm glad I'm doing this because there's a fraction answer if I haven't messed up. Negative 2x plus 10y equals to, yeah. Now I'm going to solve. And this one I definitely should check. So I'm getting y equal to 13 over 8, which is really unfortunate. Step 5, solve for the other letter. And you can use any equation. I'd like to use one that has small numbers. I'm going to use this equation right there. And what I'm going to do with this equation, it's 2x minus 5y equals negative 3. I'm going to plug in 13 over 8 for y. So I'm going to go, I just feel like I should have an error here, but minus 4x. I don't see an error. So I'm going to go 2x minus 5 times 13 over 8 equals minus 3. When I multiply this, I'm just going to multiply the 5 and the 13. This is going to give me 2x minus 65 over 8 equals minus 3. I'm going to get to my calculator here because I don't want to do these fractions by hand. So I'm going to add 65 over 8 to both sides. And on the left side, I'm going to be left with 2x. On the right side, I don't want to do that without my calculator. So I'll use my calculator to go negative 3 plus 65 divided by 8. Math, enter, enter, and I get 41 over 8. Now I need to divide both sides by 2. Or I could multiply by 1/2. On my calculator, since I have the 41 over 8 in it already, if I just type the divide and hit 2, it's going to divide 41 over 8 by 2, and I'm going to math, enter, enter, and I get x equal 41 over 16. I think the answer, and I'm going to check this because I'm not feeling good about this answer. I don't like giving fraction answers. I think the answer is x equals 41 over 16, y equals 13 over 8. It's always optional, but you can check. So I'm going to cover up my work right now and try to check this. So I'm going to try to check x equal to 41 over 16, y equal to 13 over 8 into both of the original equations. So in problem 23, the top equation was 4x minus 2y equal to 7. The bottom equation is 2x minus 5y equals negative 3. I just keep feeling like I have a mistake, but I don't see it. So I'm going to go 4 times 41 over 16 minus 2 times 13 over 8 and make sure that equals 7. And then I'm going to go 2 times 41 over 16 minus 5 times 13 over 8. And that better be negative 3. So let me check the first one. Again, all calculator work here. I wouldn't check this by hand. First one, 4 times 41 divided by 16 minus 2 times 13 divided by 8. It better say 7, and it did. So that one works, but that's not enough. Let me do this one over here now. 2 times 41 divided by 16 minus 5 times 13 divided by 8. And it worked. So it's the answer, and it's not the answer that I was hoping to get, but it's an answer. And so I'm kind of glad I did that because that's your problem as opposed to mine. And it was ugly. For both of our problems, 25 and 26, the letters are lined up so I can skip step 1. I'm going to now, for my step 2, I'm going to pick the y to drop out. Because there's a positive y in one and a negative y in the other. And I like when there's a positive and a negative in front of the letters. It makes it easier. Step 3, I have to figure out what number I can get in front of these y's. And I can't easily turn a 2 into a 5, but 10's a multiple of 2 and 10's a multiple of 5. I'm going to create a positive 10y in the top equation and a minus 10y in the bottom, because 10 is the least common multiple between 2 and 5. And that's my goal on that third step, to get the same number with different signs. So I'm going to multiply everything in the top equation by 5, everything in the bottom equation by 2. Your work's going to be almost identical. So when I go through the top equation, I'm going to go 5 times 4x and get 20x, 5 times 2y and get 10y, 5 times 3 and get 15. Bottom equation, 2 times 3x and get 6x, 2 times minus 5y and get minus 10y, 2 times 1 and get 2. Done with the third step, on to the fourth step. Combine and solve. So the two equations I threw on top of each other, I'm going to combine. Another fraction. Oh my. 20x plus 6x is 26x. 15 plus 2 is 17. Divide. Divide. I'm going to get x equals 17 over 26. Step 5, solve for the other letter. And I can use any equation. Should use one of the original ones because the numbers are smaller. And I like using ones with positives. So I'm going to use this top equation, and very specifically into this top equation, I'm going to plug 17 over 26 in for x. I can use any, well, I shouldn't use that. That's not even my equation. That's not my problem. I would really mess up if I did that. I'm going to use this top equation and plug 17 over 26 in for x. And I'm going to exploit my calculator. 20x plus 10y is 15, 6x minus 10y. That is what it is. So in this top equation, I'm going to go 4 times 17 over 26 plus 2y equals to 3. So first I'm going to do 4 times 17 over 26. So 4 times 17 divided by 26 equals, math, enter, enter. That's 34 over 13. So this gives me 34 over 13 plus 2y equals to 3. Now I'm going to go minus 34 over 13 minus 34 over 13. So now I'm going to go 3 minus 34 divided by 13. Math, enter, enter. That's going to give me 2y equals minus 34 over 13. And then divide by 2. Divide by 2. Now I just go like this. Whoops, 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 whoops. I was supposed to write, this should be 5. I should have written 5 over 13 here. Duh. I just did that subtraction. I did 3 minus 34 over 13 and got 5 over 13. Forgot to write it. Now I'm going to go divide it by 2. And then math, enter, enter, and I get y equals 5 over 26. So my answer to problem 26 should be x equals 17 over 26, y equals 5 over 26. I don't want to take the time to check this on screen because it's going to take forever. There's something that we're going to learn in the next section that would make this easy to check, but it's not a good time to introduce that. But I'm off screen checking the answer, and then when I get to the next section, I'll show you what I did. But it's too early, and I just want to make sure I don't have a wrong answer. And it's right. I did something using matrices, and I got the answer 17 over 26 and 5 over 26. In the next section, we will learn how, if we get grungy fraction answers, there's a strategy using something called matrices that we can do on our calculator to check our answers, to avoid having to do what I just did by hand here to check. Alright, so 25 is your go. And really must have been in a horrible mood when I was writing these problems. I'm really not excited about them. The x's and the y's are lined up for both of our problems. Unfortunately, I have these nasty fractions. I don't want to ever work with fractions in this section. I'm going to rewrite, when I go problem 26, I'm going to rewrite to get a nicer version of the problem. So I'm going to multiply everything in the top equation for my problem 28 by 6. And I'm not going to ever work with this fraction equation because that fraction equation is a monster to work with. And anytime I'm solving a system of equations that has a fraction equation, just like in the last group of problems we were able to rewrite it, in this group of problems I'll be able to rewrite it. So I'm going to cancel all my fractions. So I'm going to work with this system of equations. 4x plus 3y equals 18, and 2x minus 3y equals to 8. Probably when you go to do number 27, you should multiply everything by 4 in the top equation to get your fractions handled. So now I'm going to solve this system. Step 1 is already done. The x's and the y's are lined up. It's done for me. Step 2, how nice it is mine, I can skip because I have the same number with different signs in front of the letters. So I'm straight to step 3, combine and solve. Step 1 is to line up the letters, which was already done. Step 2 is to get the same number with a different sign in front of one of the letters, which is already done too. So now I'm going to combine. 4x plus 2x is 6x. 18 plus 8 is 26. Wow. I'm really not happy with myself. I don't like having fraction answers at the beginning of these problems. But yet they're there. I'm doing off screen again to make sure my answer really is going to be that horrible fraction. And it is. So I'm going to divide both sides by 6. On the left side, I get x. On the right side, that reduces to 13 over 3. I just did something on my calculator that told me that x is supposed to be 13 over 3, y is supposed to be 2 over 9. You'll learn that in the next section. It's just not a good time to teach that. So now I need to do step 4, solve for the other letter. And I can use any equation. Oh gosh. Hold it. Step 1, step 2. I kind of got my steps messed up. Step 1 that was done for me. Step 2, I picked a letter. Step 3 actually was already done. This combining and solve was actually my step 4, and this is actually step 5. I don't usually write the steps down like this, but the structure is nice. But the idea is to line up the letters, get the same number with opposite signs in front of the letters, add the equations to drop out a letter, solve, and now work with the other letter. And I'm going to use this equation, and into this equation I'm going to plug 13 over 3 in for x. So I'm going to go 2 times 13 over 3 minus 3y equals to 8, and I'm really relying heavily on my calculator. So first I do 2 times 13 over 3. Math, enter, enter. So now I have 26 over 3 minus 3y equal to 8. I'm going to minus 26 over 3 from both sides. That's going to give me minus 3y equals, and then go 8 minus 26 over 3, math, enter, enter. That gives me minus 2/3. And now I'm going to divide both sides by negative 3. And on my calculator, I just have to go divide it by negative 3, math, enter, enter, and I get y equal to 2/9. I'm done, other than maybe I'd want to check, but I'm not going to check. My answer for problem 28 is x equal 13 over 3, y equal to 2 over 9. So the letters haven't dropped out, so I haven't gotten a no solution or infinitely many solutions. Oh my gosh, this is just, not a good set of problems here. All right, so problem 29, let me do problem 29 just because I don't want you to have to do so many fractions. The letters are lined up, which is nice, but I have these ugly fractions. On problem 29, so I'm going to do 29. I'm going to go 15 times 4/3 x plus 15 times 1/5 y equals 15 times 5. And then here, I'm going to cancel and be left with 5 times 4x, which is 20x, and 3 times 1y, which is plus 3y, and 15 times 5 is 75. So the system that I'm going to solve in problem 29 is 20x plus 3y equals 75, and x minus y equal minus 2. Now I need to pick a letter to drop out. I'm going to drop out the y's because there's one positive and one negative. And when I drop out the y's, I'm going to leave the top one with a positive 3y and make the bottom one have a negative 3y. And I'm going to do that by multiplying everything in the bottom of the equation by 3. The x and the y have those ones that are implied in front of them. So I'm going to rewrite the bottom equation but not the top equation. I'm going to go 3 times 1x is 3x, 3 times minus 1y is minus 3y, 3 times minus 2 is minus 6. Now when I add these together, I'm going to get 23x equals 69. That's actually nice because when I divide both sides by 23, I'm going to get x equal to 3. Now I need to solve for y. This is probably the nicest equation to use because it has small numbers in it. So I'm going to solve for y. I'm going to use that equation, x minus y equal to minus 2. I'm going to go 3 minus y equal to minus 2, plugging in 3 for x. I'm going to minus 3 from both sides. On the left side, the 3's cancel. I still have the minus y. On the right side, the numbers have the same signs. I'm going to add them and keep them negative. And now I don't want to know what negative y is. I want to know what positive y is. So I divide both sides by a minus 1. And on the left side, the two negatives will be positive. On the right side, the two negatives will be positive, and I'll get y equal to 5. So my answer for problem 29 is going to be x equal to 3, y equal to 5. And that works. I can check that in my head. It's nice when they're not fraction answers. So a few more problems for this part of the video. I think 3 more. And then part 3. In part 3, we have 3 equations and 3 unknowns, and those problems are grungy. So I need to pick a letter, and the x's and y's are lined up. And again, I usually don't do the elimination method unless the x's and y's are lined up. I'm going to pick an equation. I'm going to pick the x to drop out. And you can pick the x as well. And I'm going to make the top have a minus 3x, and I'm going to leave the bottom with a positive 3x. You can make a negative and a positive 5x. There wasn't really a good letter to pick from because both the x's have positives in front of them, both the y's have negatives in front of them. So they didn't have any opposite signs. I just picked the x's because they had smaller numbers in front of them. And what I'm going to do is multiply everything in the top equation by minus 3. So I'm going to go minus 3 times x. That's going to give me a minus 3x. And then a minus 3 times a negative 3y. That's going to give me a positive 9y. And then a minus 3 times a positive 7, and I'm going to get minus 21. That's my new top equation. I'm going to leave the bottom equation just how it was. Now I have the equations set up. Unfortunately, I've set them up and both the x's and the y's are going to cancel, which means all the letters are going to cancel out, because on the left-hand side, the x's and the y's both cancel. On the right-hand side, those numbers get subtracted because they have opposite signs. When all the letters drop out, you're done. You just have to decide if there's no solution or there's infinitely many solutions. And for this problem, if all the letters drop out and you're left with a false statement, there's no solution. We can say there's no solution, or we can say it's inconsistent. So I'm done with my algebra. Once all the letters drop out, there's no more algebra to do. And my instinct, what I was taught when I went through school, would to say there's no solution. Our current text on campus, when there's no solutions, they like you to say that it's inconsistent, but that's kind of overkill. All right, your 31 should probably be a no solution, just because mine was a no solution, and I usually make the evens and odds pair up that way. My 34 is easier than your 33, so I'll do 33. So I need the x's both have positives, the y's both have negatives. I need to pick a letter to drop out, and it doesn't matter which. I can drop out the x's or the y's. It turns out that if I try to drop out one, they're both going to drop out. So I'm going to drop out the x's, because they have positives. I do better with positives. I'm going to make the top have a negative 8x, and I'm going to leave the bottom with its positive 8x, and that'll make the x's drop out. To get the top to have a negative 8x, I have to multiply everything in the top by minus 2. So I'm going to go minus 2 times 4x and get minus 8x. I'm going to do minus 2 times minus 2y and get plus 4y. And then I'm going to do minus 2 times 6 and get minus 12. I'm going to leave the bottom equation, 8x minus 4y equal to 12. Now I'm going to add the equations together. Both the x's and the y's cancel on the left side, so you get a 0. And the numbers on the right side cancel, and you get a 0. If the algebra, all the letters drop out, and you're left with a true statement, there's infinitely many solutions. There's technically a really nice way to write that, but let's just say there's infinitely many solutions. If you take Math 342 at ASU or some other campus and take linear algebra and you're struggling with how to write infinitely many solutions, shoot me an email and I'll give you a little lecture on it. But for our purposes, let's just say if we get the letters drop out and it's false, we say there's no solution, or use the word inconsistent. If the letters drop out and we get a true statement, we just say there's infinitely many solutions, and let's not fuss with writing the nice form, because it's just not that important. First of all, it doesn't come on any of tests that I've ever written, so it's not going to cost you any points on the test. And second of all, the only time that you might see it is in linear algebra. And to get to linear algebra, you usually take Calc 1, Calc 2, Calc 3, and then anything I would have taught now you probably might have forgotten anyways. So that's the answer to 33. And one more problem each for this video. Yours is easier than mine, so I'll do mine, 36, and you can do 35. I'm going to drop out the x's. For 36, I'm going to drop out. So notice I'm not writing the steps so much, because really, once we get the concept down, we can just run through it. I'm going to make the top have a negative 5x and the bottom have a positive 5x. And to do the top to have a negative 5x, I need to multiply everything in the top by negative 5. So I'll go negative 5 times x and get negative 5x. Then I'll do negative 5 times negative 2y and get positive 2y, and then negative 5 times 3 and get negative 15. I'm going to leave the bottom equation, 5x minus 10y equals to 15. Oh, wow. Really? Oh, I messed up here. I have negative 5 times minus 2y. This should be plus 10y. I probably said plus 10y, but just didn't write it. Obviously, I'm tired. It's the end of a long day. On the left side, everything cancels. On the right side, everything cancels. If the letters cancel and you get a false statement, say there's no solution or inconsistent. If the letters cancel, you're left with a true statement. Just say there's infinitely many solutions, and we won't worry about the fancy answer. This means that they're parallel lines. I mean, they're lines that coincide. They graph right on top of each other. So give 35 a go, and again, give yourself a good break between problem 35, finishing problem 35 and moving into the part 3 of this. It's the grungiest kind of problems, so get really good at these. The next problems have 3 letters and 3 unknowns, and we have to do the elimination method instead of 1 time. We have to do it 3 times in solving one problem. All right, so I'm going to pause the video and you can finish this up.